Okay, welcome along. So I've just started plotting. Now this time you'll notice that because I'm looking at 45 degrees, I'm not interested in breaking up the positive part of the range into two equal strips, because 30 degrees isn't involved in the multiples of 30 degrees. So what I am interested in knowing is what does root 2 look like, or more importantly, so it looks like 1, 41, 42, or let's well, I did that wrong. Let's fix that, or to 8 places. Okay, so that would be 1, 41, 42, and there's nothing particularly easy to remember here. There's 13 cards in a deck, or whatever. 41, 42, 13. Okay, well, we're not going to probably remember it. I might remember it, but you don't need to remember it. What you could remember is like 14, 14, and then that's 1.414. Okay, or else remember 41, 42, and sure, at this stage I can't forget, and I also remember that that's 56. But that's not important. It's not important to think about precision in number. But now we're going 1 over 1.414, and that happens to be half the 14.707. Okay, quickly reciprocate that, and shift equals, just look at the answer, 0.707 with very little here, or you can remember it as 0.7071. But when push comes to shove and you're doing it on graph paper, it's essentially 7 out of 10 boxes to the kind of precision you're going to be plotting in Leaving Cert. Okay, and in light of that, it probably is a good idea. It could be a good idea to use graph paper. And if I see some right now, I'll use it. If I don't, I won't, and we don't need to. So the point is, where does 0.7 live? 0.7 lives up towards the top of that strip. We'll put it there, and down towards the bottom of that strip. That's where it lives in that range, where this here is 1 and this is -1. Okay, so it's still above a half. Remember, 30 degrees gives us a sine of a half. So you get values here, 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 and so on, like so, for the question they're asking us. These are all your values. Okay. And this is extremely simple, so we'll see how much we can fit in. Oh, this is my origin here, and this is degrees. And you might wonder what I'm doing here. This is 2 pi, and this is 4 pi. And when you get the hang of it, you just know that pi over 2 is just the same as 90 degrees. Okay, pi over 2 is worth 1/4 of a circle. It's worth a quadrant. Okay. So we're going to start off with 0, pi over 4, pi over 2, and it's easier to do these as pi over 4s. So we'll go a little bit and then we might just give up, because it's a bit boring, to be honest. Okay, so we're kicking off with 0 because we're doing sine, the sine of x, and then we're going into 0.70, 71. If you want to be to just 2 figures, it's 71. Okay, and that's really all we have time for, or room for, so let's leave it there. And then we're getting to 1, come back to 0.71, and then we're getting back to 0, that's here. So there's less data. Remember, last time we'd have filled in half 0.87 in between each one of these, and this time we're only filling in 0.87. So we're going 0.7. Now we're going downwards, because we're going down in here, and we're getting down to -1. We're coming up back through 0.71. we're going all the way up to 0, and we're going to start becoming positive again. Okay. Table, we're not doing the table, we just did it. Oh, we just did the table and the graph. Yeah, we got that done. State the maximum in values of y and give the amplitude. Well, the maximum value of y is 1. Y max equals 1. Y min equals -1. And what does this say? And give the amplitude. The amplitude is equal to 1, because it's how far it goes from the midline. By drawing a horizontal line -1/√2, that's this one, we've already drawn it. Find the value of x in the domain that satisfies the equation sine of x is equal to negative, and that's the same thing, more or less, saying minus sine of x is equal to roughly -70, 71. Okay, so we read off the answers here. Now we can switch back over to degrees. There's nothing stopping us switching back over to degrees for this. So let me just write the answers in here. In degrees, this is 45 beyond 180. That's 225. Okay, this is 45 beyond 270, which is 315. This is 45 beyond, now we've gone a long way here, we've gone 360, another 180, 540, and we're just going on 45 from there. So 540 and 45 is 595, we'll be checking that. And we can go 90 on from there. Could we have done that all along? I don't think we could, but so 90 on from there is 685. And we'll just be interested in checking what happens if I do the sine of 685. So even though they were working in radians, we kind of switched back to our more familiar thing. And as I say to you, well, it's funny because radians appear to you in trigonometry. It's only in calculus when you're doing it that you need to worry about them much. Okay. So I just made a little bit of a mistake here. Let's think, this is 720. So back from 720 by 45. That should have been, hang on, back. So back 45 from that is 675. That's more like it. And look, what you're seeing is I checked and then back another 90 from that. Take 90 from 675, 585. So that should have been 85. Okay, and we want to check these if I'm so dodgy on the other ones. Let's turn that into, so that's 585. Let's check how that one would go. The sine of 315 is good, and 225 is good. Okay, so great problem solving, and we're done on that, and I'll upload this now. Thank you.